Why do we have a salt bridge? What's the point of a salt bridge? Salt bridges are used to allow ions to move around the circuit, but preventing the solutions using individual half cells to mix or from mixing. Preventing them from mixing. We know that in order to have a successful circuit, it must be a complete circuit. Now, you could have two beakers and stick the electrodes in with a voltmeter, and you would see a current flowing for a while. But eventually, you would lose the potential, would lose the momentum of the electrochemical cell, because you would end up losing concentration on one side, gaining concentration on the other. You'd end up building up too much. I don't want to use the word pressure, that's the wrong word, but you would lose the voltage behind the cell, so it wouldn't work forever, or it would stop working quite quickly. If you have a salt bridge, you allow the flow of ions to happen really neatly. It allows the ions within the solution to move. It allows there to be almost like a continuation of the circuit, and so it allows the electrochemical cell to happen better, stronger. No, not stronger, that's a bad word to use. More smoothly, I'll say. Prevents the buildup of charge at either electrode, there we go, which is going to push against the voltage, because the charge of all ions in both half cells must remain at 0 to maintain electron flow. So you don't want to build up charge in one place by moving all the electrons into one place and not replacing them, or moving all the negative charge into one place and not replacing it, because then you're going to get a pushback, you're going to get electron-electron repulsion, and your current will not flow. So you'll get a resistance to the voltage. There we go. The most common salt bridge is a piece of what soaked in what? And by common salt bridge, we mean, in laboratories, in simple laboratories, the most common salt bridge is a piece of filter paper. So this is what you would be using, or what you would be describing you would use. A piece of filter paper soaked in what solution and why? It should be soaked in potassium nitrate. Why? Why have we chosen potassium nitrate? Of all the salts that we could have picked, why have we chosen potassium nitrate? You could be asked this. We do know it, or we should know it, in terms of our theory. It's because most potassium and nitrate salts are soluble, so the nitrate won't react with any of the metal salts to form a precipitate and take that metal salt out of solution, or that metal ion out of solution. And potassium also won't react or interact with most anions that are in solution, that are counteracting the metal ion in solution, to form a precipitate and to take it out of solution and to disrupt. Also, potassium is not going to, the potassium ion is unlikely to interact with the electrochemical cell either, because it is not easily reduced or oxidized. So potassium nitrate is used because it doesn't interact with the electrodes or with the electrochemical cell, and it doesn't produce precipitates, which will remove metal ions from solution. So it won't disrupt the cell by changing concentrations. I put conks because I'm being lazy. Except